Hi, I'm Sam Sly.
I'm Quinn Jarecki.
And I'm Bobby Ursvich.
This is Optics 3D, Lab 10 Lasers, and our TA is Ian Arnold.
In the first part of the lab, we created a laser from a tube of helium neon gas as our gain medium, electrodes to pump, and a spherical mirror to complete our cavity. We initially aligned the cavity to the rail using a green heenie to avoid reflections. Notice that the end of the cavity is slanted. The angle creates a Brewster's window at approximately 56.3 degrees that reduces S polarization, allowing only P polarization delays. Next, we introduced a coated spherical mirror to complete the cavity so we could have resonance. We supplied power to the electrodes in the gas tube to begin pumping and readjusted the mirror to achieve lasing. In order to extinguish specific laser modes, spider web fibers were placed into the system to create output modes. The highest mode we achieved was TEM43.
In this part of the lab, we characterized the divergence of a Heaney laser using a beam profiler. By sliding the camera down the rail in 2-inch steps, we measured the diameter of the beam at different distances from the laser source. We then used the MATLAB program to fit the beam width equation to our data. From this, we were able to determine that our beam waist radius was 0.41784 millimeters, the divergence angle was 4.76 milliradians, and the numerical aperture was 0.00238.
In this part of the lab, we used 3 different techniques to measure the difference in frequency between 2 longitudinal modes of a Heaney laser. We estimated that the length of the laser cavity was 18 centimeters, then calculated our mode spacing to be 830 megahertz. On the electrical spectrum analyzer, we measured the spacing to be 887 megahertz. With a 10 gigahertz scanning Fabry-Perot, we saw that the given optical frequency would resonate every 2.94 milliseconds. With this parameter, we calculated that the 2 longitudinal modes are 884 megahertz difference. With the 1.5 gigahertz Fabry-Perot, we saw that the given optical frequency would resonate every 2.48 milliseconds. With this parameter, we calculated that the modes are 895 megahertz different. Because this laser has 2 plane mirrors rather than a Brewster window, there is no preferential polarization. This means that the different longitudinal modes have orthogonal polarizations. This is why we cannot extinguish the beam with the polarizer when both modes are present. And our TA is Ian Arnold.
So you have something that looks like so your delta frequency.
And we'll switch the octave for
T. Your full switch at full with half max has to be